Hello there. I'd like to welcome you to the Chapter 7 Study Guide, or also known as a Chapter 7 Review. And I'm watching all sorts of wavy lines form on the Doceri desktop. Chapter 7 Review, this is Metamorphic Rocks. So I have 20 wonderful questions for you. You will notice in this presentation that my numbering system is terrible. So here we go. Number 1, we have a red thing, and we have a plus sign, and we have a box with some arrows. So what is the red thing indicating? So that is heat. Of course, this is a metamorphic chapter. And what is the arrows squishing the box? What does that represent? So that is pressure. So these are the two agents of metamorphism, or heat and pressure. Okay, we have a rock now, a picture of a rock, and maybe a question that goes along with it. Have heat and pressure been applied to this rock? The answer is no, because this is a sedimentary rock. This is conglomerate. So now how do I know that heat and pressure have not been applied to this specimen? Well, the minerals are not lined up, or the rock chunks are not lined up, and they're still pretty well rounded, so there's no evidence of flattening. So question number 2, we're going to draw the rock cycle. So we begin with magma. Magma turns into what type of rock when it cools? That's an igneous rock. So igneous rock, if it is exposed to the elements, it'll turn into sediment, and therefore into what type of rock? Okay, sedimentary rock. So the sedimentary rock then could undergo the H and the P, which we discussed in the very first slide, and therefore turn into what type of rock? Metamorphic rock. And is it possible that metamorphic rock can melt and turn back into magma? And the answer is yes. But the question mark is for the ultimate question: is this the complete rock cycle? And the answer is no, because igneous rock can also be subjected to intense heat and pressure and turn metamorphic. Metamorphic rocks can be weathered and eroded down into sediment and eventually turn into sedimentary rock. And the last arrow is other metamorphic rocks can also be subjected to more heat and pressure and turn into cousins of metamorphic rocks. So question number 3, we have a picture out of your textbook. And I'm differentiating the red stuff down below with the other part of the picture. So this red stuff right here is called magma. Okay, I know it's a little hard to see in the picture, but what do you call that stuff that's filling in that subsiding basin out in the deep ocean? So those would be sediments in terms of sedimentary rocks. And what do you call the rest of everything that's in the picture, supposedly? Well, that would be more metamorphic rocks. So now we have the same picture, but we have some strange colored circles on this picture. We have a blue, a red, and a yellow. So here comes a question for you. Which colored circle that I have drawn on this picture represents a low-grade metamorphic rock? Which color is low-grade? And that is the blue circle, because it's closest to the surface. Now, if you look at the yellow circle, what name would you give the metamorphic rock that is encompassed by the yellow circle? Now, it's way deep down in the earth. So this is a rock that starts with a G, and it's what you tell somebody if you are hoping that they will have a wonderful day. So that is nice. So have a nice day. So in this, I guess, continuation of that question, we have the blue circle blending into the red circle, which ultimately could blend into the yellow circle. So when one metamorphic rock grades into another, what concept is that called from class? And the answer is, this is called progressive metamorphism, from when one rock goes from one to the other. And yes, I ran out of room at the very end. Question number 5, 3 black circles and a title slide here. 3 types of metamorphism. So I'm not going to give you the answer straight away. I'm going to give you some clues. The first one involves heat only. The second one is going to involve some very hot water. And the third one is going to involve metamorphism over a very large scale. So let's go back to the heat only. What is it called if it's heat only? So that's contact metamorphism. What is it called when it involves hot water? Okay, that's hydrothermal. And then over a very large scale, maybe continental scale, that would be regional metamorphism. Question number 6. This is a picture all the way back from chapter 1. So we have a huge thing that has happened to the early proto-Earth. A Mars-sized object is smashed into it. And what type of metamorphism does this represent? So this is an impact from an asteroid in this case, or even a planetesimal, so this is called impact metamorphism. And when you find evidence of impact metamorphism on Earth, you can actually find the products or the remnants of that impact, which are known as impactites. Question number 7, another picture from chapter 7, which this is. And what I'm asking with this picture is this actually a metamorphic rock? And the answer is yes on that one, because you can see it's real swirly. So now I take you to the great big USA. Where did Africa hit North America way back in the past? What region of North America was slammed by Africa? And if you guess the Appalachian Mountain region, you're absolutely correct, kind of. For the further details of that, you need to take historical geology. So if you were to drive from, say, eastern Kentucky toward the west, all the way in the central part of Kentucky, you're in sedimentary world, and then it goes to low grade, metamorphic, medium grade, and then high grade. So does this concept sound familiar, going from low to medium to high grade? And yes, you guessed correctly if you guessed progressive metamorphism. So that's blending from low grade to medium grade to high grade. Okay, now we have another picture from your textbook. And if I highlight this area here, which type of metamorphism is highlighted in the box? Okay, that is contact metamorphism. And now I have the other box up here. It's involving the hot water that's going through fissures or cracks. And that is hydrothermal metamorphism. Hot water going through cracks and fissures, leaving behind mineral goodies through dissolved ions. Okay, by the way, this is slide 3 squared. Okay, number 10, same picture but a different question. Okay, I've highlighted an area in the picture, and your job is to decide what is that called, the cooked zone. So the cooked zone in a contact metamorphism regime is called the areole. And a continuation question, let's say that the cool country rock were all limestone. What metamorphic rock product are you likely to get? And that is marble, which is a non-foliated metamorphic rock. Does the chemical composition change as it goes from limestone to marble, as the limestone is cooked? And the answer is no, because limestone has a pink dot and marble will also have a pink dot. So we're about halfway through now. This is question number 11. We have some magma that's been injected into some cold metamorphic rock. I wouldn't say cold. I would say perhaps less hot than the magma. So that's the highest grade metamorphic rock you can get, which is called, it starts with an M. This is a Magnetite. So it's a very high grade metamorphic rock. Okay, now we have a picture from another chapter in your book, and I've just turned it sideways to use in this slide number 12. Here we have this rock is being squeezed by a type of pressure, and your job is to decide which type of stress or pressure is being applied to this specimen. And if it's coming from one or two sides, that's called differential stress or differential pressure. So now we're going to explore perhaps the other type of pressure. So I got a big box that has maybe merged into a smaller box through the initiation of pressure. So the question says pressure from all sides is called, and the answer is confining pressure or confining stress. Okay, 13G, that's pretty awkward. So between a confining pressure and a differential pressure, when you consider the two forms of pressure that's involved in metamorphism, of the two, which one will produce or produces foliation in a metamorphic rock? Is that confining or differential pressure? So that is differential pressure. Okay, when two continents slam into another, for example. So now question number 14, we're going to get into the agents of metamorphism, and this is just brute force memorization. Number 1 starts with an H. Number 2 starts with a P. We've already discussed those in this dossier. Question number 3, or the third one, is the V one, which means maybe hot liquids and dissolved gases and stuff. Chemically charged fluids can also be in number 3. So between heat and pressure and volatiles, or chemically charged fluids, which one is the most important? And in metamorphism, it's always going to be heat. So question number 15, we have a rock. Isn't that lovely? Has this rock specimen undergone pressure? Has this rock undergone pressure? The answer is no, because you don't really see any evidence of lineation, as it's called, the minerals being lined up. Okay, what about in this one? Any evidence of pressure? Well, yes, it's going to be that squeezing pressure. It's going to be that differential pressure or differential stress. So, is this rock foliated as a result? Are the minerals lined up? And the answer is yes, they most certainly are. So now we're going to take both rocks and we're going to compare them with one another to see if we can establish a relationship between the two rocks. So what is the relationship of the left rock when compared to the right one? Okay, so the left one is a parent rock, it's granite, and the right one actually is the product of metamorphism, which is called a gneiss. Ooh, is a gneiss a low, medium, or high grade metamorphic rock? And the answer is it is a high grade. Okay, question number 16. Progressive metamorphism rock names. Ooh, that's super duper. So this is a fill in the blank on this question. S to P to SCH something to the G. So I'm going to let you figure that one out all on your own as I try to find the submarine, apparently. Okay, this is 1 plus 16. I have a nice picture here. And these are phenocrysts, aren't they? No, these are not phenocrysts, because phenocryst is an igneous word. Since this is a metamorphic rock in the metamorphic rock chapter, do you call these porphyroblasts? And the answer is yes, you do. Now, by the way, is this garnet or starlight? And it's garnet. Okay, 19 minus 1. This is garnet plus mica plus schist. Okay, if I add those three words up, what product do I come out with? And that's a goofy question with a goofy answer. Garnet plus mica plus schist equals garnet, mica, schist. Because remember, the schists that you have are named from the minerals that are found within it. So this is 19R, and the R stands for the real number 19. And we're almost done. This is 2 questions left. Now your job is to name the non-foliated metamorphic rocks. So here we go. That's pretty simple. We only got 2 of them. We got the M one and the Q. Okay, M is marble and Q is quartzite. Now between these 2 choices of marble and quartzite, if you were to choose between them, which one actually has a sugary appearance or a sugary texture? And the answer is quartzite. And finally, question number 20, we're going to have 2 continents, continent 1 on the left and continent 2 on the right. which are colliding or have collided in the past. And the ultimate question in the metamorphic rock chapter here at the end is, what type of metamorphism are you likely going to see there? And the answer to that question is regional metamorphism. So this now concludes the end of our Chapter 7 review session.